Hello everyone, and welcome back. So this time we're going to be doing example 2.3 in your textbooks. So let's check it out. If we look at it, we see, okay, we've got, once again, we're adding components, and we're going to get a resultant force. But this time, we actually know what the resultant is. We know that it's 400 pounds. We're doing the reverse. We want to find the components given the resultant, rather than find the resultant given the components. And once again, the angle is 40 degrees. That's just coincidental. It's not like 40 degrees is going to pop up all the time. So, how are we going to do this? Well, we're going to use our trig functions. It's always going to come back to trig functions. Now, if you want to, you can just say that's 50 degrees because this is 90 degrees here. This is 40, and so that other angle that you don't know would be 90 minus 40 equals 50. This makes it really easy to find these two components because they form two right triangles. And px and py are the adjacent sides for both of their triangles. You can see that py is touching the 50 degree angle, px is touching this 40 degree angle. So we can just do cosine of 50 for py and cosine of 40 for px, as we're about to see. So cosine of theta is adjacent of hypotenuse. Px is the adjacent side, and the magnitude p, or 400, is, the resultant 400 is our hypotenuse. We know what the angle is, so we plug that into our calculator and rearrange. Be very careful when you're doing your algebra here. You might need to walk it out step by step. What I did was I multiplied by 400 on both sides. That canceled that out. And I was good, and I plugged everything in here. Now, you notice I put 180 minus 40 degrees? This is just so I didn't have to worry about the sign. I don't actually have to do that. You just need to remember that this px is pointing in the negative x direction. So whatever value I get, it should be negative. Okay, it should be negative. Now, for a lot of this doesn't matter, but since I asked you for this individual component, it's negative. Now, many times this is based on what you define as negative and positive, but for me at least, right's negative and up's negative. So if I don't tell you, default to that. Okay, now we're going to use p and our trig functions to determine what py is, this vertical component. And once again, I'm going to do, well actually this time I'll use sine of theta. I could have used cosine of theta for if I use 50 degrees, but I'm going to rewrite it. And I'll clean this up a bit because it's getting a bit crazy over here. And so let's draw it big. So this is p, which is equal to 400. This is px. That's py. It's a terrible p. There we go. And this is our 40 degrees. And so we see that if this is the point, this is the base. So this is the opposite side. This one's always the hypotenuse. And so opposite over hypotenuse of 40 degrees is going to be sine of theta. So I plugged it in there, and once again I would do 180 minus 40 degrees, which I know you might be like, well, why in the world are you doing 180 minus 40? It doesn't matter so much at this point. The big thing for you to remember is that if you don't do this, you need to make sure that your signs are correct based on what direction it's pointing, rather than just based on an equation. So I could have completely forgotten about this and the negative sign, and this and the negative sign, as long as I realized I needed to add a negative sign, because that won't pop out on its own. In this case, it doesn't do anything because it's pointing up and it's in the positive direction. And I get 257 pounds. Now, if I want to, I can check this to make sure that it's correct. I would just use the Pythagorean theorem where c squared is equal to a squared plus b squared. Or I could say c is equal to the square root of a squared plus b squared. Then I look and I see, okay, well, let's do this. Square root of 257 squared plus negative 306 squared. Obviously the negative sign disappears because I'm squaring it, and that does in fact equal 400. So we're good, it checks out. Our answers are correct. Okay, so once again, we just used those trig functions and it helped us solve the problem. Okay, we're going to be doing this over and over and over again. So if you're weak when it comes to trig functions, you should really look at that right triangle practice worksheet and work through this problem over and over until you have mastered it. This is going to be an invaluable skill for this entire semester. Well, I hope this helped you, and I'll see you all next time. Bye-bye.